Let's have a look at gradient. What is gradient? You've seen it in the formula. Let's show you the formula. Y equals mx plus b. And we've identified m as the gradient. Well, what is it? So if you have a line, it has a particular slope. And we're going to differentiate between different lines with different slopes with a number. So the higher the number, the steeper the line. Let's have a look at the line we've got on the left there. It is climbing as I go from left to right. So that's actually a positive gradient. If I was going to drop from left to right, and let me just do one that does that. Let me just get a tool to do that. Let's just do this particular, let's not do that. Let's get it a colour that's going to be able to be seen. Okay, let's just put another line there. That green one is negative. So here's a negative one right there. It drops as you go from left to right, whereas your positive one climbs as you go from left to right. Now a slope can be a whole number, it could be a fraction, it could be a decimal. How do we determine that number, that fraction, that decimal? Well, every gradient can be written as rise over run. Here we go. Rise over run. It's a fraction. So that fraction is made up of a number on the top, which is the rise, and a number on the bottom, which is the run. Now, sometimes as you go from one point on a graph to another, you don't climb, you drop, and they are our negative ones. So let's look at ourselves on this line here. To get back onto that line, if I go off here, I would have to come back to that line in that ratio of a run and a rise, but in this case it's a drop. See, I could run there and I could drop there. So negative gradients have a negative rise, which we call a drop. Whereas a positive one, let's have a look at the positive line. Yeah, oops, don't want to completely remove that. Let's get ourselves on the positive one. Now, how do I get back on that line? I could go across here. I could go back up there. Or I could even do a small one or a medium-sized one. This is a run and this is a rise. And the ratio would be exactly the same as this tiny little run here and that tiny little rise. You would find the two fractions were equivalent. So you run along and you rise a certain number, and that gives you your fraction. There's where you put how far you run along, and there's where you put how far you rise or drop, and in which case if it's a drop it's a negative. So what have I written there? Every gradient can be written as rise over run, a fraction that says that to get from one point on the line to another, we can run along and then rise or drop. So let's have a look at an example here. Example 1. All right, there's a particular line. Have a look at what I've done in the green highlighter. You can see that to get from one point on the line to another, so we're starting here, we're going across, we're running 5, and then we're going up 6 to get to the next point. Then we can run along 5 and up 6 again to get to the next point. So my gradient is, well, every time I run 5, I rise 6. It's kind of like steps. Remember, the run is like the tread and the rise is like the riser on a set of steps. You would be going up, you would end up at the same point if you drew the steps, which we've done there in the highlighter. Positive gradients climb from left to right, we know that. So this is a positive 6 over 5. What if it was a negative 6 over 5? When I run, I would then drop. So here's example 2, and we'll do that in class. You can have a little look at what I've said there. I'll just leave it there for you to look at for a minute.